In this video, we're going to work through the practice questions that deal with parallel lines, N-sided polygons, and then we're going to look at central angles and arcs and inscribed angles. So let's begin with question 1. It says, in the figure below, lines L and M are parallel and intersected by lines S and T. Given the angle measures below, what is the measure of angle X? So we are looking for this angle right here, and we know that L and M are parallel. We're going to use these symbols to help us to remember that, and we know that S and T intersect each one of these. What I'm going to try to imagine if I can, because I'm looking at X that is created from line L and line T. If I can almost take S and just try to move it out of my mind so I don't even think about it, because it really doesn't play a part right now in finding X. Because when I look at these parallel lines of L and M, if I can remember some relationships here, I can figure this out. And there's a couple of different ways I can look at this. So given that I have this angle of 70, it is formed by two parallel lines cut by a transversal, and I also know that this angle 70, and I'm going to call this angle Y, those are same side interior angles, and they add up to 180. So I said Y plus 70 equals 180, and I can solve for Y by subtracting 70, and I get that Y is 110 degrees. Well, then I also know that Y and X are vertical angles. Again, we talked about in our review, we don't have to remember these names, but we need to remember the relationships. But those are vertical angles, and they are congruent. They are the same. So if Y is equal to 110, then X is equal to 110. And that is answer choice D. There's a couple of other ways I could have done that. I could have looked at the relationship between 70 and this angle right here. Those are alternate interior angles, and they are the same. So this one is also 70. And then I could have used a supplementary relationship between this 70-degree angle and X and said 180 minus 70. That still gives me 110. So there's several different ways that we could solve that. We could use a supplementary relationship here with this angle measure, making this 110, and then 110 and X. These angles are alternate exterior angles. They are the same, again giving us 110 degrees for X. So different ways, just know your relationships with parallel lines and transversals. Let's take a look at question number 2. It says, in the figure below, AB is parallel to CD, AE bisects angle BAC, and CE bisects angle ACD. If the measure of angle ACD is 86, what is the measure of angle AEC? So we are looking for angle AEC. So this is our unknown. I'm going to make that X. That's what we're looking for, that angle measure. We know that line AB is parallel to CD. They gave us that. And we know that line AE right here bisects angle BAC. So this angle measure, I'm going to give it double tick marks, is equal to this one, because that's the definition of what bisects mean. And it tells us that CE bisects ACD. So if I can make 3 tick marks, that angle is the same as this one because it is a bisector. That could come into play. So let's see. They give us that the measure of angle ACD is 86. ACD, that's this big angle. The whole angle ACD is equal to 86. So because we had talked about CE bisecting ACD, we know that the measure of angle ACE is going to be 1/2 of ACD. So that's 1/2 of 86. That makes it 43 degrees. So we know that this angle is 43 degrees. We're still looking for angle X, but we know that the angles in a triangle equal to 180. So if we could get 2 of the angle measures, we would be able to find the third. Well, we need to know, can we figure out what this angle CAE is? Well, let's use our relationship of what we know about 2 parallel lines. I'm going to just extend that line a little bit. 2 parallel lines cut by a transversal here. We know something about these 2 angles, angle BAC and angle ACD. They are same side interior. Again, it's just a name, but it's like the previous problem. We know that these 2 angles add up to 180. We can take angle BAC plus angle ACD, those equal to 180. And we were told that ACD is equal to 86, so this angle is going to equal to 180 minus 86. That gives us the angle measure of 94 for BAC. Again, though, like we know, we've been told that AE bisects BAC, so we can say that angle CAE is 1/2 of that because it is bisected. So 1/2 of 94 gives us 47. So angle CAE is 47. Now we can go back to our triangle relationship because again we're looking for angle AEC, and we know that angle AEC plus CAE, which is 47, plus ACE, which is 43, is all equal to 180. So let's solve for angle AEC, which is what we're looking for, and we'll take 180 and subtract from that 47 and 43, and we get 90 degrees, which is answer choice H. Now let's look at a question related to N-sided polygons. It says in the hexagon below, and when we see hexagon, we should think a 6-sided figure. Angle A measures 85. I'm going to go ahead and label that. What is the total measure of the other 5 interior angles? Interior angles, we're talking about these angles inside the hexagon, okay? So you may have remembered what the measure of all 6 angles inside a hexagon add up to. If you don't, that's okay. We have a formula. If you can remember the formula, that's what we need. It's n minus 2 times 180, where n is the number of sides of the figure, of the polygon. And we have a 6-sided figure, so we'll plug in 6 for n times 180, and that just comes out to 4 times 180, and that is equal to 720. So all 6 angles should add up to 720. We know that the measure of angle A is 85, so we're going to subtract 85 because we want to know what the other 5 angles add up to. And that turns out to be 635, which is answer choice C. So this is one of those formulas that is important to remember. Now let's take a look at question number 4. We're looking at central angles and arcs now in the next couple of questions. It says a circular container with radius 6 inches can be opened using a zipper that forms a wedge-shaped flap that forms a 60-degree angle at the center of the container as shown in the figure below. A zipper will go along one side of the wedge-shaped flap and around the arc. Which of the following is the closest to the length in inches of the zipper? So as we can see from our figure, our zipper runs right across here and then across the arc. So we've got to know the length. We're looking for how long this is. Now it tells us that it has a radius of 6 inches. So that is a start. We know this length to be 6 inches. So we could already glance at our choices and see if there's anything below 6, we know that would be out. Well, F is pretty close. It's at 6.5. I'm going to go ahead and eliminate that. If I had to make a quick guess, I would probably guess between these bottom 4. Okay, but let's go along. We can figure out the length of this arc and we'll add that to the 6. So if you'll remember, when we're looking at length around a circle, that is circumference, but we're just getting a portion of the circumference related to this arc. It's going to be a proportion of it. And we know that this is 60 degrees, so that's going to give us our fractional proportion of what we need. For the circumference of a circle, it is 2 pi r or pi d, but we are given r in this equation, so let's go ahead and use it. And our proportion that we're looking at is 60 degrees over the total 360 degrees of a circle. So this is a fractional piece times our 2 pi r, and I'm going to go ahead and plug in that 6 for r. Another thing we needed to make sure we knew, we are in inches here, and they asked for our answer in inches, so our units are good. Okay, we can go ahead and simplify here, and we could simplify our 60 and 360. That will give us a 6 there. That goes in 6 times. And then we can also even simplify there with that 6, and it looks like we're just left with 2 pi, but our answer is in decimal form. So let's go ahead and plug into our calculator a value for pi, which it should be on your calculator, or you know that pi is equal to approximately 3.14. And we know we're looking for our closest answer, so that should work. But our calculator gives us approximately 6.283. But remember, we add 6 to this from our radius, and that's 12.3 approximately. We'll round up because it looks like all of our answers are to the 10th place, and that is answer choice J, 12.3. Now let's take a look at question 5. It says, Jill drew the circle graph below describing the number of students signed up for each activity at a local summer camp. The head counselor said that the number of campers were correct, but that the central angle measures for the sectors were not correct. What should be the central angle measure for the swimming sector? We're looking for the swimming sector. So basically this person, Jill, she has drawn a circle graph to represent all of the activities for the summer, but the graph is not accurate with the data in terms of what we have. The data is correct on here, but the formation of the circle graph is not correct. What we need to look at is we need to see first what proportion of all the activities that are signed up for is swimming. So we need to find a total number. So first let's add up. We have 16 plus 6 for hiking, plus 10 for archery, plus 8 for crafts. And so we get a grand total of 40. They didn't give us that, but we can get it from adding everything up because we know the numbers are correct. And the swimming covers 16 over 40 proportion. Now, we want to figure out what should be the measure of that central angle. We know that a full circle is 360 degrees. So we'll take our proportion of what goes along with swimming and we'll multiply that by 360. We can even do some simplifying here, and we just come up to, we can say 16 times 9, and we get 144 degrees is represented by swimming, which is answer choice D. You could have also taken a look at this when we saw that the total was 40. We know this 16 is a little less than half of 40. In our graph, we can see now how this was not correct. This was showing swimming to cover half of the choices, and we know it's a little less than half. That would have been able, if we had to make a quick guess, we could have looked at our other choices. We can determine it from the information. We could have eliminated E. A would have probably been out because that's a lot less than half. You would have wanted to get a little bit better feel of your numbers by plugging in and doing the answer like this, but we can make smarter choices by eliminating when we really think about the question, think about the data that we have, and what makes the best choice. Let's take a look at question number 6, which gets into inscribed angles, and it says in the circle shown below, chords TR and QS intersect at P, which is the center of the circle, and the measure of angle PST is 45. It's labeled here. What is the degree measure of minor arc RS? So we are looking for this arc, the measure of it, the degree measure of it. We know that the relationship, we could find the measure of this arc given this angle. It is 2 times the inscribed angle, so 2 times 45, which gives us 90 degrees. That is the measure of this arc, QT. Now we can also work inward to this central angle. The measure of the central angle and the corresponding arc is the same. So this is a 90-degree angle. Then between this angle, this 90 degree we just found, and this angle RPS, they are vertical angles formed by the same 2 chords, makes this angle a 90-degree angle, the same. And then we can move forward to the one that we're looking for. The central angle and the arc there, they have the same measure. So it makes that a 90-degree angle, and that's what we're looking for. Answer choice K, 90 degrees. So we work from using our inscribed angles, we make use of arc measures and central angles. Knowing these relationships can help you find whatever it is what we're looking for on the question.